Hi, welcome back to the breadboard. Had lots of my viewers over the years asking about have an old laptop, it's broken, the screen I think still works, can I use it for my Raspberry Pi? And the answer for me up until recently has been, well, no, not really, not without a lot of effort and messing around. But a little while ago I came across some boards on Banggood. You can get them in various places. Mine I bought from Banggood, that will allow you to connect a LCD panel, and you can see I've got 1, 2, 3, 4, 5, 6 different panels here. They're all actually different makes and models, different manufacturers, and these are all from old laptops, or at least the 1, 2, 3, 4, 5 of them are from an old laptop. This one is from an old industrial PLC prototype screen HMI that I had, and it just went completely blank for no known reason. I have it quite well stripped down right now, and we'll go into that later in the video, perhaps even a separate video anyway. And so I've collected these from various laptops that people have given me over the years, and they've just been sitting in a corner thinking, yeah, one day I might be able to do something with them, or I might be able to use it to fix an old laptop where maybe the screen got broken. And when I found these boards on Banggood, I thought, oh, I wonder, and I ordered some. One of them has arrived. I have another 2 or 3 coming because I want to try and resurrect all of these if I can and use them for different projects and have them permanently being used. So I thought I'd show you a easy way of leveraging an old screen with a Raspberry Pi or anything that has either VGA, HDMI, composite, and some of them come with DVI inputs as well. So any of those kind of signals could be used and fed into one of these panels. Now, first thing I'll do is go through some of these panels and what they are. 5 out of the 6 that is in this pile are all the exact same resolution, which is 1366 by 768. I think that's what it is. So what I've got, let's just quickly go through them as a clearer way out. This one is a 10-inch panel. It had a touch panel on front of it, which I still have on the enclosure. And like I said, it went completely blank. And I thought, oh, that's great. I have to throw it out. But I've done some investigating, and I know what's wrong with it. So first thing to do is I'll show you it working, and I'll do in a separate video how I'm going to be fixing this thing. So this is a 10-inch panel. This next one is a 14-inch panel. These are from old laptops, so don't expect the screens to be perfect. And it's 1366 by 768 as well. I have tested these, so I do know that they basically work with a laptop. You can put in the model numbers and find these on eBay and various other things. They can typically cost you anything around $100 or more, depending on the size, right? This one's probably nearer the $80 as a fully working screen, but it's still, you've got to connect it up to something, all right? So if you had a laptop and the screen was broken, you could get another screen and replace it. Now, if you have an obsolete laptop and you want to repurpose the screen, then the thing you've got to deal with is this connector here. In this case, these are 40-way connectors that you have to connect into, and what they do is they use LVDS channels, low voltage differential signaling channels. This one uses a single channel, and a single channel actually means basically 6 wires plus power for the backlight plus power for the panel itself. So you need to make sure you have a controller that will be able to put out at least a single channel, and pretty much all of them can. It just, when you get to bigger panels, you want to have more than one channel, and that's where you can run into issues. So anyway, that's the first panel I've got. This is, I think, from an old HP or something like that laptop. This next panel is a 15.6-inch panel. You can see, much bigger. And control electronics down here. Now, some of the things to look at on here is you've got these inductors, and a lot of times what these inductors are for, there's 2 of them here. There's one here and one here. These are for creating power supplies. There's going to be a little buck converter or boost converter associated with these chip, and one of them will be boosting the supply voltage up, because often the backlight power is typically going to be 12 volts coming into the panel, or 7 to maybe 20 volts anyway, and the boost converter will bump it up, and typically the LED array could be a 28 to 31, 32 volts LED strip, and giving it about 20 milliamps to the panel, which gives you, a good couple of watts of backlight illumination. Now this panel, I don't know if I can show you on here, is actually cracked. There's a crack that runs right across here where the lid got twisted a bit when it was being opened, and it just went, and it was a very, very thin lid, and unfortunately destroyed this panel. So while it will power up, it's useless, so we're not going to bother trying to do anything with this one. The next panel is another 15.6 inch panel, and this one is made by LG. Now this one is a high resolution one. It is a 1600 by 900, I think it is, and this one uses a 2-channel LVDS signal to drive the panel, because there's a lot more data to go up, and with a certain refresh rates you've obviously got to use more channels so you can get it up there. What you can see here as well is the cable running up for the backlight. So over here, this is probably the boost converter for the backlight running up, and there's going to be a strip along here which is going to be illuminating the panel. There's no strips on the sides or the bottom, it's just on the top here. Okay, so this one we're not going to be able to check today because it is a 2-channel. I don't have a 2-channel controller yet. When my 2-channel controller does arrive, I will make another video and show this one hopefully working. Next one I have is another LG display. This one is a 1366 by 768 as well, again with a 40-way connector. These are all in slightly different positions, which is unfortunate because it prevents me taking one 15.6 inch display and putting it into an old laptop that I had that actually is functioning correctly, except the screen was broken, which was that screen I showed you just before. Same thing applies though. There's there's the ribbon cable in this case going up to the backlight, and then here's the little boost controller circuitry here. So you're going to feed it in 12 volts here. It's going to boost it up and feed it with 28 to 32 volts for the LED strip and power your backlight. There's also a signal that comes in here or comes out of here that can turn the backlight on and off as well. Or in some cases there is. Anyway, so that's an LG. It's a LP156WH2. As I said, these are all either different makes or certainly different models. That one over here, because that one should work. If it works, it should power up. Here's another bit grubby one. This is also a 15.6 inch. This one is actually only 1024 by 768 resolution. So this is from an older laptop. But again, a 40-way connector, and the same thing, LED backlight running up to this big strip running along the top, plastic protective strip across the board, a little boost converter here because you feed it with 12 volts and it bumps it up to 24 volts, 28 to 32 volts current for the LED strip. It's basically it's an LED controller over here. So the question is, do these work, and how do you make them work with something like a Raspberry Pi or anything else really for that matter? So what I found was a board, and they come in different varieties, but basically it's this, right? I've got a few things plugged into here, and it comes with everything that you see here. So you've got composite input, VGA input, and an HDMI input. You've got a power connector for 12 volts nominal supply, and then this particular one came with an extra input for a second composite video. And then you've got a little keypad for selecting, doing your on-screen display, select which inputs you want to use, etc. And it comes with a cable in this case. You can't buy these boards without the cable, but in my case I wanted a cable that could plug into the display. So this particular one is wired as a single channel. It's a 40-way connector, and it plugs into the pin headers on here, and this side connector is for the LED backlight. So it's providing 12 volts up, and also there's a control signal for turning the LED on and off. Now, the extra outputs on here, this particular connector, there's a boost converter here, and this is for a CFL kind of backlight, like some of the older technology backlights, if you happen to have one that you needed power for. And this connector here is for a TTL type LCD display. All the ones I have here right now are LVDS, so they're using this connector. Now, one of the things with this connector here is 1, 2, 3, 4, 5 twisted pairs there. So basically it's needing to have 4 differential pairs to drive channel 1 and a clock. And then if you look at the connector, it goes on to have LB1 to clock and 3 as well. So that will be the second channel. So this board is capable of driving a 2-channel display, but the cable is not. It's not wired up for that, and these are a bit of a pain to wire. So I've ordered a cable separately that will actually support a 2-channel as well. And I think I've got one controller that also directly comes with a cable for a 2-channel one. Everything else on here, this is just so you can break out the VGA connector if you want. Everything else, the chip has the part number lasered off of it, which is a bit of a shame. I don't know why they do that, but because it's a bit silly really. It's easy to find out what those are at the end of the day. So I guess the next thing is to actually power it up and try some of these displays. So this what the part number for this is a 2AV. Well, it's basically the PCB 800099-V.9. So you've got 2 audio videos, 1 VGA, 1 HDMI, TTL out, 50-pin connector on the board. So this one is 50-pin. Maybe that one's 50-pin, the TTL one. Yeah, TTL 50-pin. An LVDS connector and an accessories connector, which is the one that does this keypad. That's pretty much it. So without further ado, I've got 12 volts sitting here ready to go. Oh, this one comes with a remote control too, and on here, an IR receiver to have that work. So I've got some cameras here that have got composite out. Never tried them, don't know if they work, but maybe we'll see if that works with these as well. I've got an HDMI which comes from Raspberry Pi that I've got here. You can see I've got one channel on this LCD, but it is configured to work with 2 screens already. So if I plug in another screen, it should automatically power up. So let's just move this slightly to the side. Let's grab our first panel. We'll just grab the top one off the pile here and see if it works. So this one is 1024 by 768, and it's got this, as I said, this little 40-pin connector. Now you do need to be really, really careful when you're using these connectors because they are easy to damage. And if you look at these pin headers, I'll put a picture up. One side you can see the connectors, the other side looks like, in this case, just a solid green strip. The solid green goes down, the connectors go toward you in the up position, and you just lay it next to it and very gently, you don't need to force it, there's no real pressure in it, push it in, and that's in now, and that's pretty much it. So let's just gently turn this over. That's now connected. As I said, the screen's a little dirty, so excuse that. And all we now need to do is we'll plug in our HDMI to this. We'll try this separately near the end of the video with some alternative input signals. And let's just plug in the power. And I just saw the black light flickering on this. And this is powered up. And ooh, it come right in. So it searched the signal out. And there it is. So this is actually working. Now, I don't have... Oh, I can actually manage to... Yeah, so I'm actually... It looks like it's paralleling the screen, the mouse on here a little bit. I'm using my finger on the... this screen behind me is the official Raspberry Pi 7-inch touch panel one. So you can see I'm actually moving the... I don't know if you can see that. Moving the mouse on the screen here. So that screen is working. Now if I use the control here, I'm going to push the menu, bring up the on-screen display. So we can see here you've got brightness, contrast, hue, saturation, color, temperature, and exit. And if I go down the menus, we've got the on-screen display settings. So we can shift the screen slightly as well, horizontal position, vertical position of the, just lost it. That's for the shifting of the on-screen display position. Right now it's just set in the middle. So on-screen display, you can also use the remote control that comes with it. So let's just give that a little go. I guess I've got to pull the battery slot out. Let's see if that works. That's the video select, AV1, no signal, AV2, VGA, takes it a minute, HDMI. There we go, back to there. Mode select, ooh, AV1, no signal. That's doing the same thing as the video select. Oh, that's defaulting for brightness control. And if you go into menu, yeah, you can run through menu, OSD, and you've got functions like display ratio 16:9, which is what this is, sleep timer, blue screen, sharpness, mode, etc., and exit. So one of the things that you notice here is it actually says 1080p down here, and this is not a 1080p screen. But what that is, that's a function of the controller. So it is actually scaling a 1080p video signal coming from the Pi down to a, in this case, what do they say? Yeah, 1024 by 768 display, which means that you can pretty much send any signal to this within reason, and it will just automatically scale it down, which is excellent. Anyway, winner winner, as Dave Jones would say, chicken dinner. That's one LCD display proven to be nicely working here. Let's try the next one. Okay, this one is the LP156WH2 TLQB. It's an LG display made in Korea. So I've just plugged in the cable. Just turn it over gently. You do not want to stress these cables. And let's just turn this on. I'll use the remote to turn it on this time. Come on. There we go. And looks like the backlight's working. It just flashed up. And there we have it as well, which is excellent. That's another LVDS display working nicely here. Dragging around my screen just to, I'm moving the mouse just to say it's a live screen here, not just some weird thing. Menu, so it still says 1080p. The first one was a 1024 by 768 screen. This one is a 1366 by 768 screen, but it's still scaling nicely and it's still filling it out to the limits of the display, which is really cool. So that's 2 for 2. That's really nice. Let's just power this one off and put the next one in. So you need to turn it off. You really don't want to be unplugging these things with the display being driven, because you could cause some damage potentially. When you unplug these, just be very gentle. Try and keep a hold of it and just pull nice and gently and just ease it off so that you don't damage that connector. So that one works just nice. Let's try this 14-inch display. So this one is the 1366 by 768 as well. As I said, this one is from AU Optronics in China. So again, the connector is in yet a different place. This one actually sticks out over the edge of the screen. So just be careful when you put them in. It doesn't take much at all, and you just got to be careful of these connections here. Fortunately, you can order cables on their own. So that's that. Let's power it up. Come on, power up. Oh, wrong remote control. That's my video one. Hopefully I didn't turn off the video. There we go. Just saw the backlight flickering there. Come up and, oh, there we go. Another winner. That one looks a little on the dark side. Probably brightness would help. I don't know how much that's gonna. That's maximum brightness there. Could be the LEDs are a little bit old. Anyway, I'm not going to worry about playing around with that. The fact is the screen is working great. So, and as I say, these are all being driven from the Raspberry Pi. So that's excellent. It still says 1080p as you saw. So let's just turn this one off. And again, we'll just gently take the connector out. So that's 3 for 3. Now this one I think is the one that uses a 2-channel. I'll show you what happens when you try and plug it in without a 2-channel. Let's turn that around. Oh, this is the broken one. I just realized. Let me just show. Anyway, it will come on. It's just not going to look very good. As you can see, a very nastily cracked display, completely messed up. Which is a shame, because it's the mountings. Unfortunately, even though a lot of my displays are the same physical size, the tabs for mounting this in the laptop are different. So it won't screw in, and the position of this is different. And the custom cable that runs from the motherboard on the laptop won't reach to where this is. So this one's close to here, the other ones are over here somewhere. So I'd have to buy the same screen, which $100, I don't know if it's worth doing that for an old laptop. Anyway, so that one, showing you it's buggered. So let's get that one put aside. And is there another one? Yep, there's one more. This one must be the 1600 by 900 LG display. So this one is probably the 2-laner then. Well, it will be if that's the one. So we'll plug in this cable gently and carefully. And power it up and see what happens. Okay, that's it turned on. You can see the backlight flicking up there. But what's happened here is basically nothing. It flicked on, but we're not getting any notable display. If I bring up the menu, it would do something. It's flicking occasionally, but it's only got half of the data that it needs to work. So when the other controller comes in and I plug it in, hopefully we'll be able to see it work. Sometimes it will power up with like noise, see like there, because it's only being partially driven. So I don't know if this works yet or not. Hopefully we'll find out soon. So that's that one. I think that's all. Oh, yes. Now this one currently does not have its LED backlight connected, and the reason for that is because the LED backlight is faulty. That's, as I said, this screen was completely blank. I thought it had completely failed, but when I was playing around with these, I thought, I wonder if it's the backlight that's actually failed. And it's an LED one, so I didn't expect it to. So it's actually glued along the top, which was a real pain in the ass to get into. But I took it apart and I've got the LED strip out. I'll show you that in a second. But if I just plug this one in, I'll show you a neat little trick that you can use. You're going to be careful with these ribbon cables. They can get damaged quite easily. So we just take gentle care of them. So let's just plug this into here. Now, even though this is 10 inch, it's still 1368 by 1366 by 768. So if you plug that in and I power this up, you really won't see anything much happening on the LCD, right? Because there's no backlight. I'm actually just lifting the LCD slightly forward here, but watch what happens. I don't know if you can, how do you do it from the back? Maybe you can see it. See that? I'm just having it very close to here. You can see that the actual LCD panel is working. See, there's the little spire. on here. I'm shining it right through the black and the back of the panel and everything. Let me just see if I can pull forward the LCD and illuminate it from here. Yeah, you can just about make out the image there being illuminated. Yeah, just there, you see. So I know the panel itself is working, so it would be the LED strip that's not working. So that's why I pulled it out, because I actually just shone the light right through the back of here initially. Took a lot of disassembling and carefully disassembling. Let me just turn this off. We'll unplug this, put that aside. So on closer examination of this, I found that there's a chip here blown up, that's literally blown up, and this looks like it's associated with this boost circuit here. So I'm assuming it's a boost circuit, because I measured the output over here on the LED for the LED strip, and it was measuring 12.5 volts, which is exactly what was coming out of the controller. So, and then when I looked around here with a magnifier, I found that this chip here had blown itself to pieces, like score marks around it and things like that. So this had been on for months, 24/7. So it probably just got overheated and failed in a basically shorted itself out. So it's just feeding the 12 volts up, which is nowhere near enough to light the LED strip. I also found that one of the LEDs on the strip is broken as well. Anyway, I'm going to do a separate video on trying to repair this. I mean, ultimately, if you were being paid to repair these things, not worth it. You can pick this panel up for probably under 50 bucks. And even if you pay for the more reputable sources and things, you're still going to pay, you know, maybe $60 or $70 for it. So if you're getting paid by the hour, it's not worth even trying to fix this. By the time you've taken it apart, I could replace the chip on here if I could figure out what it was. Not worth it. But because the LED strip works, I could just pull that chip off or not connect it in here and power the strip from a completely different voltage source. Just a little boost converter on a separate board you can get for $1 or $2, and this theoretically should be up and running again. So that will be a different video. This video is all about this controller here. So we've had a look. Let me just get another display and put it back on again. And we'll just use this smaller one just for the example. And we'll try and feed it with a composite video signal. So just let me see if I can find something that will do that, and I'll be right back. Okay, as if by magic, my old analog security cameras have shown up. Never tested these before. Basically, they come with a little length of wire on the end of them, and you've got a 12 volt input and a composite video output. That's pretty much it. They do have night mode, so they've got some infrared LEDs in there that would turn on if the light goes below a certain intensity. And that's it. There's no focusing, no nothing. This is one is a Lorex. It's 12 volt, 220 milliamps. Output is one standard 1 volt composite. This one is a C, whoever make that is, 12 volts, 600 milliamps. This one might be quoting when all the LEDs are on. And again, video output 1 volt peak to peak. So I've powered it up, this one. I haven't tried the other one yet. 12 volts going in here, composite video coming out here. And I've plugged it into the composite 1 video input. So let's see if it works. So I'll just use the remote, pick the mode. I've got the picture here. Let me turn the overhead cam light off, see if you can see things a little easier. It's a little better. Not so much brightness glaring on the screen. So let's just select a different input. Oh, and I guess that's working. So we've now got a little camera. You can do little special effects with it. So that's cool. So that camera actually works, which is nice. So that's that one. Let's plug this one in. I'm going to have to unplug the 12 volts because I don't have enough outlets right here. So let's unplug this one. And we'll power this one up. and see if it works. Oh, little shutter in there, doing some weird things. Let's plug in the video output. Oh, and we do. There's video on this too. It's great looking at the bench here. Again, a little bit fuzzy. It's composite video. Oh, it switched to night mode. All the LEDs have come on, which is nice. It's illuminating everything. Switch back because it's brighter there. Switch back to full color mode. If I go to a dark area, it'll probably switch to black and white. There we go. Turned on all the LEDs. So, again, a little bit out of focus. It's not designed for focusing on things this close. It's designed for security, where you're looking in a much bigger area. So it probably doesn't have the, if I pull it back a little bit, it's a little sharper now because it's probably back in focus now. Looking at the same things on the bench, go to something brighter, and there we go, natural color. So, very, very cool. Looks like this works. Let's try the other input. Make sure that works. This is input AV2 I'm plugging this into. That's just connected up in here. So we'll just pick input 2. Oh, and I guess that works as well. So you could have both cameras here and you just switch from one to the other if that's what you wanted to do. Night mode. Day mode. The other camera is supposed to have a night and day mode as well. It doesn't like being put on its face. Let's just flip back to the other one for a second. Just want to see if that's got night mode as well. It's supposed to have with all those LEDs there. Let's just turn the lights off. See if that helps. Yep, there we go, instantly. Yeah, night mode, so that works fine. So, as far as this nice little board is concerned, you've seen I've given it 6 different LCD panels, one of which isn't supported because I don't have the right cable yet. The other ones all seem to work fine. I've been driving them from a Raspberry Pi and I've still got that. I can just switch inputs. So you could use this as part of a home automation system, for example. Put this in a box, have a Raspberry Pi behind it. You could have a couple of security cameras, one at the front door or something, and switch to it if you wanted to see who's at the front door, if you hear the doorbell ring. Otherwise, it could be running a Raspberry Pi application and things like that. Now, you can also get touch screen overlays for things like this, which would allow you to also plug, it usually comes with a USB. The one that we looked at earlier, which was broken, which I'm going to show you in a separate video fixing, hopefully, that does have a matching 10-inch touch screen that goes on the front of it, so you can use it with the Raspberry Pi or Windows or whatever. Anyway, so my answer that I used to give about can you use old laptop screens on a Raspberry Pi, etc., is now converted from a no to a, well, absolutely. You just have to get one of these kind of boards. They range from, you know, $25 to sort of $50, depends on the types of inputs and the resolutions supported. These boards, this one here, I think, I'll put a link up, but I think it was in the region of sort of like $20 or so. And as I said, it's got 2 composite analog inputs. It's got a VGA input and HDMI input. Runs on 12 volts. You could use this in a car. You could have a reversing signal feeding into this. I think the connector has the ability to signal the chip directly. So if you hooked it up with your reversing on a car, you could have it automatically come up and then show you the reversing camera. Otherwise, it could be playing multimedia in your car or something like that, or acting as part of an on-screen display for the car. Just one of the possibilities. Either way, these are very versatile little boards, and you can get them in different configurations. Some of them come in long, thin strips, so you could use it with a panel and maybe have all the connectors on the bottom of it. I think if you look at a lot of LCD screens, that you normally buy. It doesn't matter whose make it is. A lot of them, you see that they've got all the connectors along the bottom that are supported. I can almost guarantee you that you'll probably find that if you looked inside the standard LCD screen, you'd find a board similar to this. And if you think about it, there's usually these 4 or 5 buttons. Maybe they're touch buttons, maybe they're real buttons, but they're 4 or 5 buttons. You would have a composite input, potentially a VGA, an HDMI, a DVI, variations of that. So it's really, you're making it into a full-blown external screen. You just don't have the case for it. You can pick up screens really, really cheaply, but a few $100. But if you're getting an old laptop for free, maybe the laptop's crap, but it's still got a reasonable screen on it, hey, be perfect for home automation. You could show the weather and to-do lists and things like that on one of these. Lots and lots of possibilities. Anyway, I think I'm going to wrap it up there. I've shown you this board. I've shown you that, taking all these different screens from a laptop works very well, except for one of them, and I think I know why that is, because of the 2-lane versus 1-lane LVDS input. And then I've shown you this working with composite from old security cameras. That composite could be from other things too, like an old VCR tape recorder, or take your pick. So works with the Raspberry Pi. It'll work with Windows, basically anything that can feed it an HDMI signal. These boards won't work with 4K inputs. They'll only work with, I think, up to a 2K signal, from what I remember the specs saying. I'll put a link to the Banggood product, and you can see all the specs for yourself anyway. There are ones that will do 4K, but obviously they can be a lot more expensive, and there's no point in having 4K if your screen is only 1024 anyway. I don't know what the highest resolution you can feed in on the HDMI, and it still will scale it. Obviously we're seeing here that it's working quite happily with a 1080p signal. I think that's about it. So I'm gonna wrap it up there. If you liked the video, give it a thumbs up. If you didn't, well then don't. But I think this is one that a lot of people have been asking for over the years, and so here it is. Yes, you can convert an old laptop LCD panel, well, wherever you get it from, to work with a Raspberry Pi. Just buy one of these boards.